Welcome everybody to our third webinar on insect processing. We had already two webinars, one on the basics of insects, and a couple of weeks ago we had the second one on rearing on insects. We will be recording, this is a very important information, this webinar like we did in the prior ones, and make the recording and the presentation available on our website. So if you have missed the last two webinars, feel free just to go on our website and you will find the registration in our media library. On the flow of the webinar, we have foreseen a question and answer session at the very end. And if you're using the Teams app, you can see there is a Q&A possibility. So if you have, during the presentations, some questions, please use the Q&A, not the chat functionality, to raise your questions, and we will be going through your questions at the end of the webinar. So what we are talking about today, we are talking on insect processing, which is mainly consisting on three parts. Bernd Pütz from Reinhardt will be talking on the dry processing of insects. So this is one alternative. And Dirk Sindermann will be talking from GEA on the wet processing of insects. And we will wrap up by Arthur, who will be talking about automation in the processing of insects. And as I said, we will end up the whole webinar with the question and answer sessions. So we are looking forward for a lot of questions. And so I will quickly go through the presenters. As mentioned, Bernd Pütz, he is the sales manager of Reinhardt. Bernd, I've been working with Bernd for quite some time. He's a real expert in the insect industry, well connected, and he is on the sales sides of Reinhardt and contributing as well a lot to ento-connect themselves. We have Dirk Sindermann, and I'm really glad that we have convinced and persuaded Dirk to do his presentation. He is the Director of Process Technology in GEA, which is a large industry and international player in the industry, and has a proven track record as well in insect processing. So he will be giving you insights on how to wet process insects. Arthur Kühl is my co-managing director of ento-connect. So the two of us and Reinhardt have founded ento-connect, and he will be talking about automation. Arthur's background, he has done a lot of projects, I would say more than 40 on a global scale, and building up insect processing facilities. And myself, just quickly, I'm the co-founder in ento-connect, and my background is more in the consulting side. And I will be focusing mainly on the costs and business cases, and we have done already quite some work on consulting founders who want to create a farm on their business plan and helping them to structure their documentation. So I will straightforward hand over to Bernd to talk about dry processing of insects. Bernd, your turn.
One second. So here we are, here we go. So, hi everyone. I'm Bernd and I'm working here at company Reinhardt, and I'm really happy speaking about dry processing of insects. So working here at company Reinhardt means that I am employed here in the technical sales department since already 3 years, and I am in that lucky position to live, I can say so, to live in an insect bubble in all those 3 years already. And just my slide, if you want to contact me after the presentation separately. It's not a problem. We are company Reinhardt in means of that we were founded in 1852 already, and in 1912 we settled over in the Neuss Harbor area. You find that building here in the background again, and we started as a machinery and machine manufacturer and producer mainly for the oil industry, and we specialized quite early in cold pressing technologies in means of that we value the oil seeds to produce a highly rated cold pressed oil or a very protein rich press cake, which was used for feed in the former years. Actually, it is a completely different topic as well. And how did we make it into the insect industry? That happened to us. Mostly this happens by accident, that we were asked many years ago to make some test trials, test pressing with dried insects, and for sure that were dried BSF larvae, which we pressed first. And since those first days, we made a lot of trial pressing here with other insect species as well. So it is mealworms, let's say yellow and lesser mealworms. Even I think there's also a giant mealworm. I'm not sure if we already tested it, but we also pressed and tested crickets and some more exotic things like silkworm pupae, which was interesting to learn as well. From those first steps and days, we moved forward and we developed by growing from a single equipment manufacturer to a process solution manufacturer, and that we are offering complete process lines in the dry rendering or dry processing, as well that being involved in the insect scene, that we are also able to do those typical tasks in regard to networking, that we have a lot of experience in engineering complete BSF facilities. There we are very strong at the moment, and we see that the last purchase orders, they were real engineering tasks, which we are covering with our engineers as well. Yeah, let's jump into the topic of dry processing. Dry processing, yeah, we can have a look on a typical insect farm as an example. And we see that the processing, or some say post-processing, is only a small fraction of such a whole installation or typical industrial installation or industrial facility. We will see that we get some information about the sieving, which is one of the first processing after receiving the larvae from the rearing area. And then we go directly into the drying and the pressing, which means the separation from liquid and solid. Okay, sieving, everybody can imagine. We have the live larvae, and we have already the converted former substrate, which should be now something like a almost dry material, maybe a residual moisture of about 10%, something like that. And if we have done everything fine and nicely, we have a real spread between the big live larvae, which are normally live and vitally, and we have the dead and fine coarse material of substrate, and this should be separated or fractionated in a simple sieving process. And simple means it can be simple vertical vibration sieves or screens. It can be a separation table. There are different technologies available. I just put in some manufacturers which came in mind first, but you know best from your area and where you are operating. There are so many sieving equipment manufacturers. So maybe you will share your experience with us, who is working good and who is doing fine. And you can imagine if you are a small scale producer of insects, then you can use simple technology And the more you grow, the more your production capacities are growing, that you may look for much higher sophisticated sieving technologies, air sifters or combination of that, air and sieve, like Custos is doing. That would be a nice option to test them, but you already need some capacities. Dry processing, yeah. This is what we are doing from the beginning, coming from the cold pressing technology. It is just super simple that we have the live larvae, we have to deactivate them, we will dry the larvae, and after drying, we already have, let's say, a sellable product. It is a product. Full fat dried larvae is still a product which is traded in a lot of areas in the world. Or if you want to climb up the value chain, you can go to separate the dried larvae into an insect meal, protein-rich insect meal, and an insect oil, which is also a highly valued product meanwhile. If you start with a simple block diagram, we have to go into practice, and then you will see in the process flow diagram that we have the machinery shown, and we also put in the values, the capacities, and which are the consumables and what is needed. You see that there's a dryer shown, that you will receive the dried larvae. The dried larvae of here, in that regard, it is BSF, which needs, it is a little bit uncomfortable. BSF larvae, they need some preconditioning before you go into our screw press. Other insects or other species like mealworms and crickets are not that tricky in pressing, at least. And after the pressing, we have the solid fraction. Maybe you need some kind of conveying and cooling. You have a milling to get a homogeneous, fine coursed meal, which can be handled into big bags, for example, and the oil coming out of the larvae will be first collected in a so-called crude oil tank, and then it will be purified, and there are as well different separate purification and filtration technologies available. You already see here that all equipment used here is already, how to say, typical technology in different industries like agriculture, like food and feed technology, and or producing industry. And this is no rocket science. Everything is quite simple. It is reliable equipment, and this is used in a typical dry process. We will jump over into detail. First, again, we have the already sieved larvae. They are separated from the frass. We have to deactivate them. There are other names like blanching people use, or the simple devitalization of the larvae. This has to be done in a very, how to say, we have to respect the animal welfare, that the killing happens immediately. And this is mostly done by boiling water, or if you go into a larger scaled production line, you will maybe use overheated water or steam. With the dryer, we have the first big point in the typical process, or the dry process, that drying technology seems to be very expensive, and we can say it is expensive in relation to something else. We have first seen that in a typical insect facility, the processing is quite small, but within the processing, already the drying takes maybe a half of the potential invest or possible invest you have to do. If you are still on a small scale, it is easy to find some typical air drying equipment like a drying chamber, oven, or pre-convectional drying. Like most simple thing will be solar drying, which is also a potential technology in some areas of the world. Other air drying equipment is a fluidized or fluid bed dryer or a drum dryer. In that regard, we have a fluidized bed of the larvae, in which they are either, most common is the vibrating bottom of such a dryer, in which the frequency of the vibration brings the larvae in a certain flow, and by the free flowing air through the dryer, the evaporated water will be transported away. This process is quite good to maintain and to handle, so that you are able to run quite close to the needed temperature, that you see how much water is already evaporated. By permanent monitoring, you see when you can go out of with the larvae, with the product out of the dryer, and when you start the cooling down of your material also. Not that high sophisticated, maybe a little bit below, especially in regard to investment, is the contact drying with the disc dryer. In that, what is shown here in that picture. It can be also a batch cooker, you can find it also in the rendering or fat industry. And by contacting the larvae with the hot surfaces, also the water inside the larvae is evaporated. Some technology also known in the food industry, or maybe also in the Asian areas, is, because of low electric costs, is the microwave drying. It is super simple in regard that you do not need those peripheral installations with air condensers and so on. That is just a quite long tunnel with a microwave. But a pain point is that most microwave users, they are very good in firefighting. In regard to metal impurities you have from time to time, you need some operator's intervention in that regard. Anyhow, we look on the product of insects. We have seen that these insects going in there in a very bright way, and they will leave the microwave dryer also in a bright way. And we have spoken about potential investment costs. And this all leads us into some kind of an evaluation matrix. As said, drying equipment is quite expensive related to the total investment cost in processing. The dried larvae, already mentioned, that is also a product which can be sold, or you go into the processing. First, it is a preconditioning, and then we are already in the screw press. Here you see a big Reinhardt's screw press in operation. These, when we talked about larvae drying, these are microwave dried larvae. It is a very, very bright cake which we receive. As well, the oil is very bright as well. You can find on YouTube a short video which is showing this big machine in operation. Here, for that speech, I let the video out. So, the insect meal. From the screw press, you will receive the insect meal in everything, like between powder and a very coarse material. This can be even small pellets. This means that we need another processing step behind if you tend to have a very homogeneous material at the end. And the oil, here you see an example for when BASF oil at room temperature, it is almost, or in most cases, it is a fat. And if we handle it with higher temperature, you will have it like an oil, which it looks like a window in the winter, when the first ice flowers start to grow, when it gets colder and colder. You see as well some impurification, and for that reason we also, or already mentioned, the filtration process at the end of the oil handling. Purification or filtration process is quite nice because you remove the impurifications or the solids from the oil, and then you have a nice oil which has also a very, very good shelf time, at least. Yeah. In the beginning of the process, or in the beginning of the processing, we have removed the insect frass, and now the question is what to do with the frass. There are different potential markets available or seen actually. It can be biogas, it can be the classic fertilizer, or you can go into organic agriculture if your whole insect process is also organic, for example. Other ideas are thermal heating for combusting, things like that. Everything is possible. We have to keep in mind that within the European Union that we have to sanitize or hygienize the process or the frass. And this is something around to hold above 70 degrees for 1 hour, the temperature of the frass, that any microbiologic load may be reduced, so it can be brought out to the fields for if it shall be used as a fertilizer. We will see what happens, which other markets will come up. So also in regards to biogas, we should maybe take into account some local potential of building circular use in means of we first have the biomass, which is converted by the insects, and later on it is used in a biogas installation. Something like that is possible as well. Yeah, at the end, I'm quite good in time, so not too much talky. We have looked on the dry processing. It is something where you have to make your decision at a certain point. We have learned that dry processing is super simple. That we have also taken into account what is locally available and what is best suitable for your process, for your later products, and so on. And something which is still open, we have to look on the quality. So actually, we do not have any quality standards in insect products. I know, and we are part of a working group, that something will happen soon or later. But typical quality standards are also already in use, that you are asked in regard to digestibility or solubility of your later protein products. And we think that dry processing, or we are very convinced that dry processing is something to meet the highest quality standards by ease. Yeah, we see that the complete killed or deactivated larvae, that it is all the containing materials, the proteins, the oil, and so on, that they are well protected by the larvae or insect body in the drying process. This is so super simple, and this makes it so that the dried larvae are that high valued product at the end. So yeah, what happens as well with the dry processing, we have also something that we still keep it super simple, that we are living the KISS principle. And as mentioned already, protein content, solubility, digestibility, these are those quality standards which become more and more valuable for your potential products. And what we see is that there will be a certain spread in super huge and super big installations. And I think it will go to countless small installations as well. And this is a trend what we are already seeing actually. What can be also possible is that your total business case of running an insect facility can be split in more successful business units in regard to that you give away the breeding, or you give away the rearing, or you just focus on the rearing and don't care about processing. Everything can be thought and should be analyzed in detail. What we also like to say that between being a small insect farmer and becoming an insect farmer in a certain big amount or industrial scale, yeah, what does it mean? What does scale, what does amount mean? We say that actually that maybe for BASF, something between 500 kilograms or 2 tons per day of fresh larvae. This is still something which can be named as a pilot plant. But it sounds much or it does not sound much. That depends on you. But we see that 2 tons or up to 2 tons of fresh larvae, that a lot of operations within that insect facility can be done by operators manually. That's a connection between separate or several separate process steps can be connected by manual operation, or maybe some adds and helping hands by a mechanical use or something like that. But this is still a more or less manual facility. And everything above that 2 tons, that is already something in which you should think about a higher grade of automation or something like that. But for the small ones, we will have those pilot. Oops. Okay. We have those small footprint pilot scale solutions, and as well we have those big industrial solutions in our portfolio. And this is something where we would like to have the discussion with you. You see our people. I think this is a May calendar sheet here with our Reinhardt staff, and here it was in a bigger installation in Asia. We have already a nice amount of references and number of machinery outside. And as said, we would be glad and happy to get into contact. And at the end of the session, as Bernd already told us, we will have the time for questions and answers. Thank you very much.
Thank you, Bernd, for such a lot insight. I would say as well, basic message to take home. There is not one size fits all. You need to take a look what you are going to plan. And I see a lot of claps, so I think people like what you told. I still refer as well to the question and answer sections. Right now we have already 3 questions, so please feel free and use the Q&A session to raise your questions, so we can, let's say, answer them at the end of the overall session. I'd like to hand over to Dirk, who will now talk on wet processing and show you an alternative way of insect processing. Dirk, go ahead and start with your presentation. Thank you.
Yeah, thank you very much. Special thanks to Bernd for that very interesting presentation. It's also always nice for us to see what our colleagues are doing. It's a pleasure to be invited, and let me share my screen. I hope the technical issues will work, and I can directly switch to my presentation, and hope that this works now. Perfect. So I'm Dirk, representing GEA. We will show you a little bit who we are. We are also in the world of insects for many years, and we have the pleasure to show you an alternative processing. We will at the end talk a little bit about the differences so that you have a little bit of an understanding. We will guide you through what we are doing in the so-called wet processing. So I will talk just a few words about the GEA group, telling you where I'm coming from, because as the other Bernd already said in his introduction, we are a relatively large group, and insects are an important part of our overall strategy. I will talk about that. And then I will focus on the wet processing, the basics, and I will talk about especially the main difference that we see to the dry processing, that is the stick water, because we are first of all separating mechanically. We will give you a little bit of insights, what we have learned with the references we have done so far, with the testing we have done so far regarding raw material and the impacts on the end products, and what is the impact of different processing on the end products, where we have to focus on. As I said, we will look a little bit on what happens in the comparison to dry, because this is what we have now seen from Bernd. So maybe it gives you a nice comparison, and you can recall what you have heard from Bernd. But we are, of course, very open to discuss a lot of things that you might have then a little bit later in the Q&A session. And as Bernd said, for Reinhard's, testing is a critical part, piloting is a very critical part. So I will give you some ideas where we probably can help you, or what we have done so far, even at a pilot plant at one of a very nice reference in Denmark that I will tell you at the end of my presentation. So let me start with GEA. Just a few words. As Bernd said, we are a relatively large organization, but please don't be afraid. We have business units, we have divisions focusing on your specific needs. We are relatively large, working in 62 countries all around the world, employing around 18,000 colleagues. You can see us on the stock exchange in Düsseldorf. We are listed in Düsseldorf, but that's all something you can read. What is very important for me is our company's purpose. We call ourselves really Engineering for a Better World. My job is within GEA Westphalia Separator. That is the picture that you see in the middle and on the right. We are located in Westphalia. We are producing centrifuges since 1893, and we are looking for really different alternative proteins. We are looking for alternative fuels beside many traditional applications. We are originally coming from the milk industry, and proteins are a very important part, and proteins from insects are the topic of today, and they are with us already for quite some time. So what have we done for that application? We have derived something what we are doing more in the fish industry. So we have been in fish oil processing or fish oil recovery. We have been in fat melting for centuries, for many, many years, or for decades, sorry, but nearly for 1 century. When you remember what you have learned in the first webinars, then you have learned a lot about the rearing and the harvesting of the living larvae. What we will focus on today is the processing. We start, like Bernd has said, with we call it devitalization. So of course the larvae needs to be, let's call it, killed in a way that hopefully the insect doesn't feel pain. We need to reduce the particle size, so we call that grinding, for the consequent separation into the different fractions. And to do that, we also need some heat. We still have low temperatures, but we need some heat, because also, as Bernd has mentioned in his presentation, we are not talking about oil, like we have oil from rapeseed or sunflower. We have more fat, so we need a little bit of temperature to have it in a liquid form that we can later on mechanically separate it. So we can separate that one into fat. We have the insect meal that needs to be dried. So everything that you have heard about drying is also relevant. I have left it out in that presentation because we have already learned a lot about drying. And you have, and that's the main difference in our process, an additional phase. We call it the stick water. And during this presentation, you will hear a little bit more about that. Well, let's start with the first stage, the devitalization. As Bernd said, it hopefully is very quick. The insect hopefully doesn't feel pain. I know that there is some research going on in that topic. I'm not a biologist. I'm a process engineer with a little bit background of chemistry and process technology. So I know that there are experts out in the world who can give a better overview of what's relevant to larvae. But we have checked with them that if we are applying hot water on a relatively high temperature, meaning close to the boiling point, and apply that like blanching, that is kind of state of the art. I mean, there are some countries, and like I said, we are a multinational company like Reinhardt. We have to look, of course, not only at Europe, we have to look at all of the world. There are some debates going on whether you can grind it directly. We keep that to the experts. We keep that to our customers. We offer that devitalization. The water that we are adding here to blanch, to kill the larvae, is removed via a vibrating screen. Let me tell you one thing. What we have also seen beside the killing is that when we do it in this way, we already deactivate the enzymes of the larvae itself, and that later on has some consequences on the quality of the finished product. Because when there is enzymatic activation that is not stopped, you have a little bit of this browning effect that you might know when you cut an apple and you have the open apple there. It turns brown, it gets brownish. And to avoid that with a larvae, this process stage is also a consideration, not only from animal welfare point of view. Then you might remember, after this killing of the larvae, the devitalization, we go to the next stage. In our company, we are also producing grinders where we can cut the particle size. Grinding itself is an important issue. I will come to that a little bit later. When you're talking about smaller plants, the grinders that we are producing might be a little bit too large. And this is what I also would like to highlight. We not only come in with our equipment. If we find that for your specific needs, there is better technology available, we also look and scan the market. So here we found a German supplier building pumps where we have a cutting device at the right-hand side, and that has the same effect like a grinder. You cannot do that for larger capacities. Larger means 5 tons plus or 4 tons plus, but for smaller ones, there are really alternatives available. And that is what we are also trying to put into our systems to have the best solution for our customers. And then, of course, after cutting the larvae to smaller size and after heating it so that we can actually have a free fat, we have a liquid fat, we come to our main component, our core component that we build at Westfalia Separator, GEA Westfalia Separator. That is a horizontal centrifuge. What you see here is a cross-sectional drawing giving you a slight idea. I will not go into all the details, but what you basically do is you put a suspension, we call it here the feed, that is this the larvae basically, into this rotating chamber. You have a high speed, several thousand G acting on the product, but still being gentle. So on the left-hand side, with a moving scroll, we discharge the wet solids. This is important. They are to some extent dewatered, but they are still what we call technically wet. And then on the right-hand side, you have the separation of the fat and of the stick water. That's the main difference to the dry process. We are, at this stage, still separating mechanically. We haven't applied heat to evaporate the water, so we still have a water fraction, and that's maybe important to note. What's the difference when we refer to dry and wet? Wet because of the stick water that we are getting from this stage. Normally, here you can achieve already a fat that is quite high in quality. You can put it into a tank, or I know that our colleagues from Reinhardt also offer something for smaller, medium-sized plants to really end up with a high quality fat, or maybe there's a little bit of filtering, there's maybe just a static sedimentation. But I have to say, we have also, and we come to that at the end of the presentation, delivered larger plants, 5 tons plus. And there, what we also can do is we can offer a different type of centrifuge that is in addition to the decanter. That's a vertical centrifuge. That's a disc stack centrifuge. Some of you might know that from the oil industry or from the milk industry. Again, we put a liquid, in this case, the fat coming from the decanter, and we can further polish it. I will not go into the details. Unfortunately, we don't have the time for that, even though I love decanters and separators. But if you have questions regarding this type of technology, then of course you are welcome to contact us and we'll give you much further insights. Those machines are designed to the specific needs, and we'll come back to that also a little bit later. As said, the water phase as a third phase, when we talk about wet processing, that is something that some people refer to as a problem. Well, yes, it is a third phase, and somebody has to do something about it. In dry processing, you are directly evaporating it when you have the drying up front. Here, we have it in a liquid form. So in very small plants, and depending on the local facilities, you can probably go to a wastewater plant with that. There is, I have to say, a little bit of remaining fat, just a little bit. There is some dissolved protein in it. And that is the point where you could say, well, why really waste it? Why not use it? And what we offer within GEA is a concentration stage for that. We can evaporate the water. That's basically a concentration. So we are removing a lot of the free water. We bring the water to a concentration of maybe 20–30% dry matter, depending on the evaporator. We have different types of evaporator. And when we do that, I will not go through all the figures given in this example. You will probably can look at it later when you get the handout. The idea is to concentrate the majority of the water in that stick water and use the remaining solids, and you can, as one alternative, add it to the stream of your solids. You remember your decanter, you have some solids, and those solids still need to be dried to make it a meal that you can store and that you can use, like what we have already seen in dry processing. If you are adding this water, you can boost the protein content, you can make better use of it. And that is not something that we have invented for the insect industry, but that is a common process, for example, in the fish industry. So that's just applying what we have already done for many, many years in the fish industry. And another alternative that we can offer, and I have to be honest with you, that is probably something when you go to very specific products. For example, in the food industry, if you want certain functionalities of the protein of the end product, or when you go to larger, much larger capacity, 5 ton plus, instead of adding the concentrate to the wet solids coming from the decanter, you can dry it as a separate stream. And why do you do that? You have a product that you can see here as one sample. It's a very light product in color. It has a very high digestibility. It's really a different protein fraction. And for those of you who have probably listened to the Insecta some time ago, you can even do further processing. So there is a little bit of additional investment necessary. So it's probably not interesting for all of you, but we just want to show you, for those of you who want to create a special product with a high solubility, it can be an alternative to not just add that water back, but dry it in spray dryers that we mainly built in Denmark, and use it as a separate fraction after a concentration. And then you have a very, very nice extra meal. So you have a more lower solubility, and you have a high soluble insect meal with completely different characteristics as a third product. Right, so that's basically the main processing points that you should keep in mind when talking about wet processing, and you can look at that probably a little bit later if you want as well. And we have asked ourselves what could be interesting for you as additional take-home messages. What we have seen is that the raw material itself has a very strong impact on the end product characteristics. And I'm sure that those of you who have joined webinar 1 and 2 in this nice format have probably already seen what the different alternatives are. And that is why we come up with some standard plans, we come up with some standard layouts, but we really sit down with our customers and do some further evaluation. Therefore, yes, there are to some extent some standards available, so we are not starting from zero, but every single line needs to be really to some extent adapted. We want to understand especially what do you want specifically with your end product. And what we call here the spin test, that is what we will see on one of the next slides, is a very powerful tool. It's not rocket science in terms of very, very highly sophisticated chemical analysis, but it gives us a nice overview when we take the larvae, process it in the lab, and do a kind of a pre-treatment like we do in the plant. We have already a pretty good idea of how the fat will look like, of how the different solid fractions will look like, and where there might be something where we also need to go to a process together with you and checking if we can do something different on the way how you work on your larvae. And of course, I always tell people, what are you doing in process technology? You are a machine building company. Yes, that's right. But we already also look at ourselves a little bit like being a cook, being a cook in a kitchen, and we build kitchens because we are combining different gear or other equipment to make it a complete line. And what we see also as a trend is that beside the traditional meals that we mainly use for animal feed, especially when we want to convert it to something that we might use as an ingredient for the food industry, things like color, smell, digestibility, or other advanced functional properties like gel strength, solubility. We talked about that when we can spray dry it, for example, the water binding capacity. That strongly depends on how we can do it. We can't make your product better, but we can try to be as gentle as possible in the way how we treat it. Therefore, wet processing works on low temperatures. The devitalization, we talked already about that, has an impact, for example, on color changes. The grinding is an important one, the mechanical separation, and as also my colleague Bernd said, the drying. One example, for example, when we look at the grinding, as I said, we at GEA also build grinders. So my colleagues in the Netherlands, where we do that in Bakel, the Netherlands, have a huge experience on grinding, and what looks simple from what we know from our kitchen can become a little bit more complex when you look at the physics of a knife, and this what we call the whole plate. So it is important that this all is adjusted to what you want to do with insects, that it's kept in a you can imagine like a knife, head needs to be sharp, and that has a strong influence later on the separation. So what you see on that on that left picture, that is what I refer to as that spin test. Here it's hardly to see a separation. A grinder has been used that wasn't sharp, that wasn't adjusted, so it was just squeezing the product. Whereas on the right picture, we see a nice split of fat in the middle, this gray area between 65 and 90% is that stick water. And then at the bottom, you see a lot of solids. So there was a kind of good and nice grinding, and that's how we want to have it. And it has a strong influence. Another example is, of course, our core equipment, the three-phase separating decanter, as we call it. Here you have a lot of different settings possible, bowl speed, the scroll speed. We can change the settings of that machine online, so you can influence the quality of the fat, and you can influence the quality of the stick water. And also the different design issues like the bowl angle, the way how you design your bowl has strong impact on the separation. And this is something we have done for more than 100 years. So we have a little bit of experience on how to do that. If you have something that you want to use and are not sure if that's suitable, come and talk with us. We can look at it and give you some feedback if that's a good idea to test it with that. We have also test machines available where we could find the perfect settings for your specific product. And another one is the stick water. I really want to highlight this in this presentation because stick water is one of the main differences compared to dry processing. And we talked about that the way how we process our stick water, whether we concentrate it and add it just back to the finished meal, or whether we have a separate stream and dry it and have a separate product. That, of course, is a strong process-based influencing factor on your end product properties, in functionality, in color, in what have you. And we already touched that point. We come to the end of this presentation, especially when we want to go to food grade. But I also know that for certain pet food manufacturers, this is a very important point. It's the cleanability, it's the sanitary design, and I can only highlight, especially when we do that for the wet processing. We, as I said, we are from the dairy industry. We build plants for the pharmaceutical industry. That is very high end, but we have a lot of know-how how to implement that to also a wet plant if necessary. And there's concepts available for what we call cleaning in place. So you don't have to take apart the majority of the product of your equipment. You can basically press a button and the whole thing cleans, as shown in this example here. So for those of you who might be interested, we can talk about that later. Yeah, so at the end, what is the main difference? I again want to highlight, it's that stick water, it's that water when we compare ourselves with a dry processing. That makes the huge difference. You have seen already there is possibilities how to treat that separately or how to add it back, or maybe for smaller plants, how to just give it to your existing water treatment. I mentioned already, I know that you can also work on low temperatures on the dry processing if you work with special equipment. For us, the low temperature, the lower product temperature is always the case. We don't work on very high temperatures where we are already boiling or evaporating the water. Even when we evaporate it with our evaporators, we work under vacuum. Our dryers, when we spray dry it, work under low temperature. So temperature is one of the issues to have gentle product treatment. And I think also when we look at the perspective of food and the possibilities how to combine it to make it a safe food, CIP is relatively easy on wet processing. The investment, especially if you have certain equipment, is very often a little bit larger. The capex is a little bit higher and compared to dry, but because of the mechanical separation, you are removing the majority of the stick water. So your dryer can be a little bit smaller for the solids, and especially on the OPEX side, on the operating expenses. When we look at larger ones, 3 tons, 5 tons plus per hour, Lavi, then I think, especially when we look at energy expenses that we have these days, it might be also a good alternative to look at the possibility to remove the majority of your stick water mechanically before you go into a dryer. So it really saves operating expenses. What you can do is, and I'm glad that also my colleague Bernd has mentioned that, we can offer a test facility here in Oelde, Germany, Westphalia. We don't have a dedicated insect processing plant, but what we do is we bring in all that equipment that you have seen for your specific needs and can create this kitchen on short notice so that we basically can simulate your process. So we can simulate it in the lab in our test center. So we can give you a couple of kilograms to take home and you can do your testing. And then we can also scale it up, because I think scaling is an essential issue. You can do a lot of mistakes when scaling it up, and scaling also is important to be tested unless you have done it yourself, to save you from mistakes that you can do once you build a larger plant and do significant investments. And the other thing is you can also do it at a production site. I'm changing now from our own pilot to what we do with our dear customer Enorm in Jutland, Denmark. He is having the luxury of having an own pilot plant, and they can in his kitchen still change some recipes, work on doing that. And I think that is also interesting. If you want to change something and you're not really sure how the market reacts on that, you want to check digestibility, you want to check market acceptance with one of your customers, they still use a pilot plant. They started with a pilot plant, but have that pilot plant especially for that in place. And we are happy to show that to you in case you are interested in Denmark as one of a possible example. They work on black soldier fly. We have done that also for mealworm and other larvae like fruit fly. My last one is what we are doing at Enorm this year to scale it up. And this is probably giving you an idea why scaling up is a critical thing and why piloting is so important. Here you can see really a significant investment these guys are doing right now. It's a greenfield project in Jutland. And beside a lot of scaling, what they need to do in farming and rearing, harvesting, they also need to scale up their whole wet processing, what we have seen, and of course all the learnings they can take from that pilot we have done together with them, saving or is reducing the risk of doing something wrong when you scale up to this level. So here we have significant investment, and errors being done here would be, of course, much more expensive than doing learnings on smaller scale. So that's basically what I wanted to present you today. If you have further questions, we are glad to talk about that later on in the Q&A session. And if you want to reach out to us, you can get that later on. I'm just part of a team, and we have even more people working in our GEA world within your specific area, country. So please reach out for your sales representative. We have own people. They are fully employed by us. They are not representing other equipments and therefore focusing on what we are doing. And we are glad to help you here in Oelde with your specific insect questions. So that's it from my side, Bernd. Thank you very much for giving me the chance to talk a little bit about that. And yeah, I'm glad to receive also some questions later on in the Q&A. Thank you.
Dirk, a great thank. I think a lot of information and a lot of expertise again. And I think I'm really glad that we have presenters like you and Bernd to show the expertise we can bring in as a network as well. We've already got quite some questions, so please keep on asking. There is one more presenter foreseen, which is Arthur, who will be talking about automation, and then we will jump right into the Q&A section.
Great, thank you. So thank you to our two Bernd and Dirk for making the introduction and giving the two nice presentations about dry and wet processing. Yeah, so basically I'm trying to not really close the loop, because the loop is closed, but give you some, let's say, more insights on the possibilities that we have in terms of automation, in order to even enhance and increase the possibilities that we have from the process side, and kind of link it into the automation and IT world. So I'm personally very happy that I have the chance to speak about that, because I'm extremely passionate about automation. I'm doing this since a long while, and I'm always stunned when I see new technologies coming up like edge computing, IoT devices. No worries, I will not bother you with that. But I would like to give you some insights from our, let's say, day-to-day work on how this industrial automation kind of fits into the world of insect farming. And here you see the spread between industrial and farming, but both can work relatively nice together. So the objective of my presentation will be to give you a high-level overview of what automation can look like, what automation can give you. There is no need to understand what is happening really in depth. It's just important to know that there is a huge spread of possibilities available. I'm pretty sure when you will reach out to Dirk or to Bernd or other possible suppliers, that they can help you very well with all the possibilities. But it's important to keep in mind that, let's say, automation data is very essential for your production goals. So basically, the automation equipment themselves during the last decades became relatively cheap in comparison to the cost that we had before. So if we speak of a relative simple controller, just picking the example of Siemens, it just cost a few €100, and you can more or less automate such a complete line. So regardless whether it's a dry or wet line, so the basic costs for this PLC are relatively low. So therefore, when designing such facilities, it absolutely makes sense to check what kind of or what degree of automation makes sense. So both processes normally are, let's say, fully automated, but the difference basically comes when you will kind of define what kind of data points you will need at the end of the day, and most important, what will you do with the data? Because the data, it will be available. You will have a PLC, you will have a bunch of sensors in place, and the question is, how do you, let's say, structure that data? And more important is how you do the process control of it, and how you do the optimization of such a process. So there are some, let's say, fancy names available like Six Sigma, etc. So you cannot work on your process if you don't have enough data available. So therefore, in order to get a, let's say, better understanding, so most of you might have seen this triangle of automation, and I will not bother you with the details. So basically, what we have on the ground floor, we have the so-called, let's say, field level, where we have the insect farm, also including the processing. And in that field level, we will have a set of sensors in place. We will have a set of actors in place that are generating signals, data, analog, digital signals that are transferred to the layer above, the PLC layer, where all the logical controls, the ladder steps, for example, like Dirk and Bernd explained in the dry or wet processing. So one step is taking place after the other, and during that, a bunch of data is created. And the question here mainly is, so in most of the applications, there is a cut and that's it. So nobody, or I would say not nobody, but most of the plants are not really making that much use of the data that is available. Why is that the case? Well, because all the levels that are coming up here, so a SCADA system normally is in place when you have a bigger installation. Some management systems or ERP systems, they are not always connected to the field level because there is some work to do on the interfaces. But the list of benefits, it's extremely long, and it gets even more easier to kind of make the link between these two. Just as one example, we have the interface here, OP3OR. So you remember the PLC that I just mentioned, the very cheap one from Siemens, for example, could be any other brand. It's built in, it just costs a few €100, and I will show you how you can, let's say, kind of get that data, and it's nice what else you can do with that. So to give you some ideas what kind of data can come from that. I just have the examples spreadsheet in here of a, let's say, sample processing here. So, for example, normally when you are working in a small or a smaller scale, then you operate it in batches, or even if you do it in a continuous process, at some point you have to make a cut and to draw the line between the mass balances. So the amount of data that you can get is relatively big. So starting with obvious things like batch number, date, starting time, end time. You can also kind of generate a lot of data from the product itself. So that data can come from online measuring. I think the most easiest part here is the temperature. So then obviously you can also measure the moisture. It can be a manual input from the operators, or you could work with online sensors, but that's a bit more complex. Also with oil, there are possibilities to do that online, but mostly you have that done in the lab, and then you can kind of link that to your process. So then you can collect a bunch of data from the dryer. This is just a very high level set that you can get from the dryer. So the biggest parameter set from a dryer that I've seen was over 100 data points. And if you imagine that these data points, you can get them once a second, you can imagine what kind of huge matrix you can build with this data. In terms of the screw press, same story. So there you don't have like 100 data points, but we can generate a significant amount of data. And then at the end of the day, either online or by hand, you will get the batch results. And here it starts to get really interesting, because if you would like to monitor your process, then you need to understand how you can link these results to the process parameters here. So there are some, let's say, simple built-in functions if we stick to the example of a spreadsheet. So a spreadsheet can do the work. You can link it to historical data. You can do some artificial intelligence stuff with that. But normally that's an overkill. So here, just a simple look at the numbers can give you a lot of insights, and experienced operators they would love to work with this set of data, because they know exactly what is happening and they know how to, let's say, improve their process. So I briefly touched this point. So capturing the data. This is one thing. Handling the data is the other thing. So just to give you some examples how the data is normally captured. In a very simple setup, a handwritten spreadsheet that is well designed with the relevant parameters. This is already an excellent starting point, because if you would like to improve the process with higher performance, higher reliability, you cannot just simply start. You need data. Without data, you cannot measure anything. So therefore, a spreadsheet is a good starting point. If we have it automized within HMI with the SCADA system, in most of the cases, we have a built-in visual trend function. The trend function can also have an archive that goes back, whatever, or the amount of data sets that you have purchased from your vendor. You can also create automatic CSV files or Excel files that are stored on a local device. They can be stored on a network. So here you can go back years and years and years and check what was out there. Then you have the OpenCR client server connection. So I think in the handout you will see it more clearly. So it's extremely simple. I was really astonished when I first tested it a while ago. So this is a built-in function in the PLCs, and here you have a freeware that you can freely download, and you can check all the data sets that you are getting. So in this case, it's from a BSF production site where you get data points from a screw press. You can get currents, speed, dosing speed, temperatures, and this entire setup costs around 200 euros. So it's nothing. You need Ethernet, you need a simple controller, and that's it. And on the other hand, here, you have some more advanced features like industrial edge computing. They have kind of built-in functions where you can create your own dashboards. So there are multiple vendors on the market where you can get these industrial edge computing devices. They are storing the data either locally or they are storing it in the cloud, and you can get really, really nice insights from that. So most important, so after we have highly scratched the surface of what's possible, so why should we do that and why should we make use of the data? So the answer is pretty obvious. Yeah, so the entire world now is living on data, and some people say that data is the new gold. Well, if you know how to use it, that might be the case. So basically, the idea behind that you cannot optimize your process if you cannot measure it. So that this is something that you have from multiple other industries. So this is not new and not only specific for the processing plants. But if you speak of things like processing capacities, if you speak of OPEX, so Dirk touched the point that operational costs are extremely crucial. And if you don't have any idea how much energy your process is using, and you can easily get all that data from your automation, it will be really hard for you to make some business models that will kind of validate what you're actually doing. So you can create useful benchmarks. So benchmarks, depending on what kind of targets you have. So know your audience. If you are about to create benchmarks for your quality management team, it will be completely different than to your business administrators that will look at the operational costs, or your production team that will mostly look on reliability of the process, of capacity, etc. The other thing is that obviously you would like to reduce the variation in your process. So the list of potential topics that can influence the process are relatively long. And if you can measure it, you have a great starting point in order to reduce the variation, to keep your quality high, and also to optimize your process. So you can run, as I mentioned, a set of data analysis. So some very simple built-in functions from Excel or other programs. That's very, very straightforward. You can improve the availability and basically get a very good understanding of the process for yourself, or if you have new operators coming in order to show them what is happening. You have a brilliant quality control, so your quality management team will love you if you can supply them with a big set of data. And as I mentioned, you can run reports, manual reports, automatic reports that give you full insights of what is happening. So wrapping it up quickly, automation is absolutely necessary and key. And I would highly recommend to automate, to measure whatever is possible if it's economically suitable. So a simple temperature sensor doesn't cost a lot. If you use an infrared sensor, it will cost you 20 times of these costs. So therefore, always keep the economical scale in mind. Collect as much data as possible. So data storage, it's not really expensive anymore. So you can easily get cheap drives, or you can use cloud to store that. The other thing that I already mentioned briefly is that you don't need to learn in depth what is happening on the automation. It's just crucial to understand what's possible with that, because it will help your business to thrive, and it will also help you to improve your overall production. So technology, it is evolving extremely quickly. So it's really tough to keep up with everything that is coming up, not only in let's say in daily life, what comes with new IT solutions. It's exactly the same case for automation. So availability is important, and safety is extremely important. By safety, I mean cybersecurity. So that means if you set this up, availability should be priority number one, then safety, and then cost. So obviously, everyone has a different interpretation, but if it's not safe, then it's not available. And if it goes down due to a cyber attack, that's a huge mess. So you should avoid that. And lastly, I would highly encourage you to follow our upcoming webinar series to learn more about the insect world in general. And very likely there will be also some interfaces to automation and to the process topics that we just recently covered. And I would say I reached the end of my presentation well in time. Many thanks.
Arthur, many thanks, giving your insights and sharing your experience with the people listening to the webinar. Before we head into the question and answer section, as I have seen that quite a lot of people have joined the webinar during the webinar, so they haven't heard what I said at the beginning. Just to restate, there is a lot of information in these presentations. So if you want to re-look and go through the presentation and the webinar again, we will make this available. Please give us a week or two to let's say post-product the recording. But we have been recording and are recording the webinars. So, and it will be available on our website in the media library. So you just can go back. You can see webinar 1 and 2 already being there. Webinar 3 will be posted as soon as we have, let's say, cut and polished the presentations. We will jump in the question and answer section. Again, please keep in mind, all of us are on the website. You can find us in www.ento-connect.com. So if you have a question to the individuals presenting here, feel free just to touch base with them and send them a message. As well, I strongly recommend we have a forum on our website. So if you have further questions we are not covering today, so feel free just to raise your questions in our forum and our experts will get back to you with some answers. So having said this, we now jump into the questions, and we have quite some questions. Some have been answered already online. Nevertheless, I'd like to go through. So as I know that the Q&A functionality is not available to everybody. So first question being, and that went to Bernd Pitz, is what do you mean by preconditioning of dried black soldier flies before processing? The answer is already there. Bernd said that preconditioning in means of tempering the larvae before pressing. So Bernd, I think that means giving them the right temperature, right?
And not only the right temperature, we learned from the presentations that BSF larvae are a little bit uncomfortable in means of that the oil inside the larvae is a fat at ambient or room temperature. And then we have to lift up to temper the larvae to a certain level that we make the oil much more and much better available during the pressing process.
Okay. Next question being from Yannick. He has been asking to Bernd, what is the shelf life of insect oil? Bernd, you have already given the answer that you can assume 9 to 12 months of shelf life of insect oils. The next one is coming, and I hope I pronounced the pre-name right. Gert, he has been asking, and I think the question goes to Bernd again, how much oil is typically retained within the press cake? Are there factors that can influence this, Bernd?
Yeah, on one hand, we have that typical industrial standard figure in something below 10% of residual fat content. This is just because that if the press cake would be much more or would contain much more fat, any after or post-processing will be quite difficult. Things like conveying or milling, grinding the press cake is only possible as long as the residual fat content is low. What can influence this? Yeah. First of all, the input material should be in a good quality that oil can be removed on one hand. Some people even are looking for different substrate recipes to influence the oil composition inside the larvae. This is a high fancy actual trend. Everything in regard to the later use of those insect products which are manufactured or produced. And for sure, during the process, you have a lot of parameters in which you can adjust the process, either mechanical or just by processing in temperature, moisture, and things like that, which have a big impact to the residual fat content as well.
And
Okay.
if I might add to that one, especially what Bernd said, when we can confirm that we see a similar effect, especially when different larvae is processed, maybe being fed with different substrates, that has an impact, for example, on the fat color. So fat quality can be, to some extent, also influenced by that. We can also, from our side, confirm that.
Okay. Thank you. Next question coming from Ridaya. It's basically Bernd has been talking about 2 tons, and it was not obviously clear whether Bernd was talking about 2 tons a year or 2 tons a day. I can shortcut that. Bernd was talking about 2 tons a day for still being manually processed, and then of course scaling up. I think you gain experience. Next question is coming from Nishi. How do we ensure nutritional value, mainly protein, in dried larvae? Do we need any testing or certification in our first attempt of processing and drying larvae? I think still going to Bernd, or is this for Dirk as well?
Yeah, the question, I'm not sure that I understand it in the right way. For sure, drying has an impact to the product quality later on. What we learned is that there are some differences between microwave drying and other air drying or evaporation or contact drying. We see as well that generally the drying results in very good, leads to very good results. We often see with contact dryers that we have a solubility of higher than 90% in peptides. That's a very good value, and this is a typical value which you also find with the people from the fish meal industry, that they are lucky with those values, and that is fine. The question is testing, doing, or certificating. You will see it with the dried larvae. You will make those typical tests in the laboratory. As said, solubility and digestibility will be tested there. You will have some first testing that are simple sensoric, like what is the smell? Is there some burnt material inside? Things like that. But this is all already coming from the oil seed processing as well, that you will not bring in burnt material in which you can be sure that proteins are maybe degenerated, and you will have a more lower value or lower quality values here.
Okay.
Maybe let me also add one additional thing, and that is maybe a more general answer, because we get these kind of questions also very often. What's the functionality or nutritional value of the especially protein meal? And I would like to highlight again, this is why I've also put that into our presentation, the possibility of doing some tests, the possibility of doing some pilot plant tests or lab tests. I think that is can be a very powerful and helpful tool, because it starts that calculation, especially in a startup industry where something starts. We don't have always, let's say, a full list of specifications available. Yeah, we are still in a way where certain standards are evolving and they're developing. And what we see as a very powerful tool is really doing this kind of testing, whether it's on very small lab tests or doing that in a pilot. And then having really a little bit of end product that also can help our customers to go to their customers and get into this contact. And then really you define more clearly, what do you mean by nutritional value? Because it's a very broad thing. And yeah, as Bernd said, I can confirm to what Bernd said, and I just would like to mention testing here can be a very powerful tool to overcome misunderstanding and accelerate your process to become a successful producer.
Okay. There's another question to Dirk. What is the protein content of stick water? Dirk, you have responded, but nevertheless, please give a quick.
Yeah, I'm glad I can quickly comment it. You have seen probably what I've shown there on the grinder. That grinding can have an impact on how much is actually dissolved. It can have to do with temperatures that we can adjust. Not so much with the decanter itself, maybe a little bit if we have a separation where we have also some protein as a what we call carryover. And again, it's a little bit the question what I tried to draw in my presentation. Whether this question is, I want to have it as low as possible because I want to send it to my wastewater plant. There, of course, you want a low protein content because it would be a loss, it would be a lower yield, and it would maybe be an issue for your wastewater treatment. But if you come to a certain value where it makes sense from an investment point of view to really create a nice additional product out of it or add it to your meal, then maybe even higher protein content can be the goal. So the question would be, maybe Yannick, we can come in contact a little bit later. What's your purpose? What's your goal? We can even add enzymes in some cases. So we have processes in the wet processing where we're even adding enzymes to actually dissolve a lot of the proteins to bring them to the water phase and then have a high soluble product, even a concentrate, or with even more advanced technologies, including filtration and isolate. So unfortunately, maybe the bad news, an easy question that can lead to a very complex discussion. It's again understanding what your customer wants, and then we can probably guide you to some possibilities.
Okay, thank you, Dirk. We have still quite some questions. I would suggest we are already, let's say, getting to the timing end of the webinar. I suggest we will do 2 more questions. As I said, we will capture all the questions and provide the answers. So don't worry if we cannot touch your questions online. We will do that offline during in our forum section. We will post the questions and the answers there. So, and as I said, you are always free to touch base with the presenters directly. Okay. What type of rendering, wet dry, is more suitable, gets better price for which animal products, wet dry, dog, cat food, or fish? Dog, fish. Also, basically the question which way to go. I think that refers to both Bernd and Dirk.
Also complex answer.
This is super complex. Yeah, so there are, even if you just have a look in the pet food market, you will find those dry food, wet food companies. They are specialized on that processing. I do not know what they prefer, if they even just ask for frozen fresh larvae. I have no real idea. And what is more suitable of we see that there are a lot of scientific elaborations and that people are looking for the right insect meal as a nutrition for different species and animals. They are testing a lot, they are doing a lot. We know that a lot of those feed companies are as well testing with insects. And if you ask one of those those feed companies, you also will be referred to specialists for chicken and hen, for swine, and for the piglets, and for the adult hens and things like that. That is such a broad customer potential which is in the insect, so it is not an easy answer.
And maybe to add there, it is not an easy answer. We have probably a lot of overlapping area when we are in certain sizes of plants. To be honest, if I had a request from somewhere where we are really looking more into something like 2 tons per day, then probably to start with a dry system is, economically speaking, probably more probably make more sense. We have a relatively large area where 2 systems can make a lot of sense. And I would say right now, especially with maybe high drying costs, if you had really a large capacity, and especially in the feed industry, it can happen. So we have in Thailand a project where we are talking 10 tons per hour. There, of course, what I said, you have the advantage when you mechanically separate the water that you can save a significant amount of drying energy. But of course, it again depends on your local availability of gas and other resources. So it's something that we can probably discuss at the end in a more detailed way. It would be too complex to give it in a 2-sentence answer.
Maybe a quick last comment on that. So beside the, let's say, price topic, quality topic, it's also a question of availability of the product. So if someone is requesting products for a huge scale plant, and that plant, or the client is a small or middle scale producer, obviously it doesn't make too much sense to bring that small amount of product into that huge processing line.
No.
Even if you accumulate it for a while, so there is some shelf time we have to keep in mind. So therefore, I think the trend is that you see most of the clients that doing dry processing, that it goes into animal products like pet food, because the quantities are lower. If you go to really huge plants, wet processing, then aquaculture comes more into the game, because they are just simply demanding a bigger amount of product. Obviously, there are other possibilities of kind of combining the products in order to gain a critical mass, but there we are, let's say, still scratching the surface in terms of product standards in order to have a standardized product that can go into these facilities.
Okay, so I would suggest also we have still quite some questions waiting. We need to make a cut. As I said, we will capture all the questions. You will get your answers in the forums. Just bear with us. It may take some couple of days to get it all transferred and all posted there. But we make sure you will get the answers of the questions. As I said, the recordings will be made available in our media library. And maybe a last hint would be as well, you're always free to ask questions to any of us presenting here. So for me, to wrap up the webinar, one more mentioning is the last webinar in our series. Webinar 6 is a webinar mainly with an expert panel. We will make sure that the expert who have been presenting will be in this webinar again. And this would be as well a great opportunity to ask further questions. First of all, thank you to everybody participating, listening to our presentations, and we are always looking forward to get your feedback, recommendations, what we can improve, what you would like to learn about. And yeah, many thanks to our presenters, Arthur, Dirk, Bernd, great insights. I really have to say thank you. A lot of work put into it, a lot of expertise brought to the table. As I said, and I see a lot of hands clapping, I can nothing say more than I appreciate very much your contribution. So that's it for today. Maybe one last word. The next webinar will be is already planned. So take a look on their website, registered if you have not done so far. we as ento-connect, maybe just a word on ourselves, we are the network to bring together these expertise. So we as a company offer as well, besides our website and community services, like we do workshops actually to give you some navigation. So it's more not so much deep down into technology, but if you plan a project, we can accompany you developing your business case, your approach going forward, navigate you through that, and bring in the right expertise, the right companies to develop your project and then going down the road. So thank you again, and to everybody, and I wish a nice weekend. And yeah, I'm really glad about all this good stuff we can present here.
Thanks a lot.
Bye-bye.
Thanks. Have a nice weekend. Thank you. Bye.
Bye.